Quadratic application word problems. Okay, so in this lesson we are talking about word problems and how to answer them, especially really talking about quadratics. One thing that you need to remember with quadratics is that your answers are always going to be focused on the parts of the quadratic graph. Now, on the quadratic graph, when you have a quadratic equation, your quadratic equation is going to look like this on the graph. So what you want to do is you want to graph it, okay? And it's either going to open down like this, or it may open up like this. Most of the time, it's going to open down like the first one. Your answers are always going to come from the y-intercept, the maximum, or the x-intercept. These are where your answers are always going to come from. The hard part is just deciding which one of those three it's coming from and whether you're looking for the x or the y. So you just have to use a little bit of common sense on what number you're looking for. So this is just the max, okay? Your x-intercept is here, your y-intercept. Now remember, your y-intercept is also the starting point or your initial value. So anytime you see those words used, you are going to give the y-intercept. You're going to give that number. And the y-intercept is going to be 0 and then some number. So obviously you're not going to give a 0. You're going to give like whatever y value that is. You're going to give this number right here, okay? So whenever you see these words right here, you're going to give that number right there, okay? Whenever it's talking about the maximum value, like you may see the word max, or you may see like a height, like what is the maximum height, or stuff like that, you're going to give a y value. And we're going to do examples of stuff like that. And x value, you may hear words like, when it hits the ground, when it hits the water, stuff like that, that's going to be the x value, because literally we're talking about stuff like when it goes up and when projectiles go up and when it comes down and hits the ground, or when it hits the water. If we're talking about money problems, you may hear like breaking even. Okay, breaking even. Of course, this is going to be, it could be hitting the ground or the water. Okay, so breaking even, hitting the ground, or hitting the water, that's going to be this point right here. Okay, so let's get started. All right, now they're also going to change the variables in these. So remember, t is always represented time, and it represents x. Okay, so t is the same thing as x. H or D can be height or distance, and it's going to represent your y-axis. It's going to represent going up or down. Okay, now when you are typing this into Desmos, okay, when you type this into Desmos, it's always a good idea just to use x and y. So don't type in your other variables. Always use x and y when you type this into Desmos, okay? So for our first problem, after t seconds, a ball tossed in the air from the ground level reaches a height of h feet given by the equation h equals 144t minus 16t squared. What is the height of the ball after 3 seconds? Okay, so if we go to, let's see, Desmos here. Let's see, let me clear this stuff out. All right, let me get to Desmos. Okay, so our equation is 144, and like I said, you just want to use x minus 16x squared. Okay, so let's zoom out just a little bit so we can see our parabola. Okay, so here's our parabola. All right. So first of the ball after 3 seconds. So after 3 seconds have passed, so remember time is x, okay? So what I'm gonna do is I wanna know if x or t equals 3, okay? So I'm just gonna put x equals 3 in the equation. And I'm gonna zoom in here. And right there, you can see that dot right there is where the intersection is. So 288, I can see that that intersection is 288. So that is my answer, okay? So the height is 288 feet. And I could have just as easily plugged in 288 feet into the equation. I could have done 144 times 3 minus 16 times 3 squared. Or you can just plug it in to Desmos as well, and it is faster. Okay, what is the maximum height the ball will reach? Well, that's the top of your parabola, okay? So the height, the top of the parabola, so if I go here to the top of my parabola, okay, so the maximum height, that is your y value. The height, that is how high, that's a y. How high is a y, okay? It kind of rhymes, so hopefully that'll help you kind of remember that those two things go together. High is y, so 324 feet. Okay, find the number of seconds the ball is in the air when it reaches a height of 224 feet, okay? So this is a y, okay? That's a y, 224 feet. So if we want to find that, so what I'm going to do is I'm going to get rid of this, and I'm going to type in y equals 224, and I'm going to go down here, and I'm going to see that it gives me a line right there. And when it reaches a height of 224, so notice there's two different times when there's two different seconds. There's when it's 2 seconds and 7 seconds when it's 224. Well, the way the question is asked, it says find the number of seconds the ball is in the air when it reaches a height of 224. So at 2 seconds, so when it first reaches a height of 224, so we would put 2 seconds. So it doesn't just say when is it 224 feet, okay? So when it reaches, so kind of the way that it's worded, so like the ball is going up in the air, so we would say 2 seconds. Okay, because what's happened is, like, just imagine, like, if you throw a ball up in the air, it goes up, and the ball comes down. After how many seconds will the ball hit the ground before rebound? So once again, if you throw a ball up in the air, you throw the ball up, the ball comes down, and it hits the ground before, like the ball would bounce back up. So we want to know right here when that ball hits the ground, which is when it hits that x-axis. So if we go down here, so we want to know right here on the x-axis, so at 9 seconds, our time is at 9 seconds. Okay, so it's just all about finding the parts of the graph. So it's just all you got to do. It's easy just to type this on the graph, and it's just learning how to read the graph and picking out the parts of the graph to answer your questions, because all you got to do is just click on the parts of the graph to be able to answer your questions. Okay, so for our next equation, let's go and enter our next equation on the graph. So a rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into a lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by negative 16t squared plus 64t plus 80. So let's enter that equation. So negative 16. Remember, we would just want to use x's instead of what they give us. Okay, I'm going to zoom out just a little bit so I can see my parabola. Okay, so here's my parabola. What is the height of the rocket after 1.5 seconds? So remember, seconds, that's your time, so that's x. So I'm going to do x equals 1.5, and I want to find that intersection, so there it gives me the dot. So the height is 140. So 140 feet. What is the maximum height? So the maximum, remember, that's the top of the parabola. So I just want to click on the top of the parabola here. So the height, how high is your y? So that's 144 feet. How long will it take for the rocket to hit 128 feet? So remember, that is a height, that is a y. So we're going to put y equals 128 feet. So y equals 128 feet. And it just says, how long will it take for the rocket to hit 128 feet? So after 1 second and after 3 seconds. So it doesn't specify like really which one. So let's give both answers. So we can say after 1 second and after 3 seconds. So if I ask a question like this in your assignment, then I will accept either answer. You can tell me 1 second or 3 seconds. So you just give me either answer. Only give me one, but you can give me either answer, okay? After how many seconds after its launch will it hit the lake? Okay, so remember, if it, here's our graph. If it goes up and it comes down, this right here is the lake, okay? That part right there. So we want the x-intercept. So let's go down to the bottom. We're just going to go down. So right there, so after 5 seconds. Okay, and so once again, if you're typing this stuff into your assignment, you would just type in the number 5. Don't put in the words, you just type in the number 5. Okay, so one more question here. A rock is thrown from the top of a tall building. The distance in feet between the rock and the ground after t seconds after it is thrown is given by d equals negative 16t squared minus 4t plus 382. How long after the rock is thrown is it 370 feet from the ground? Okay, so let's go and enter our equation into Desmos. Okay, so we have negative 16, so x squared minus 4x plus 382. And it wants to know how long after the rock is thrown is it 370 feet. So that gives us a height. So that's a y. So when it gives you a height, that's a y. So you'll do y equals whatever the height is. Okay. And so that's 370. So we need to go up to where we can see 370 on our graph. Now, notice here, we have one value over here on the negative side, okay? Well, that doesn't make sense to say after negative 1 second. That makes no sense after a negative time. So since that doesn't make sense in context of the problem, you obviously want to give me the 0.75 seconds. So after 0.75 seconds. Okay, so these are the easier ones. Just plugging them in on Desmos and just clicking the points. And like I said, the hardest part is just figuring out what points. It's just either find the maximum, the y-intercept, or enter in your own y and finding that intersection, or enter in an x and finding that intersection. Now, these next problems, we are developing our own equation. Okay. But now, these problems are going to be set up the same way every single time. There's a certain way that they're set up, And we're going to practice these, and you're going to have some like these in your assignment, but they are set up the exact same way every single time. There's a certain way to set them up, and set them up the same way every single time. So, problem 4. A farmer decides to enclose a rectangular garden using the side of a barn as one side of the rectangle. What is the maximum area the farmer can enclose with 80 foot of fence? What should the dimensions be to the given area? Okay, so let's go right here where we got some room. I'm going to go up here at the top. So first of all, if let's see, I've got, let's see, here's his barn. It's not a very good barn, but there's his barn. And if I'm going to draw, like here's his fence that he's going to use, okay? So he's got 3 sides of fence because he doesn't have to use one side of fence, okay? We don't know the sides that he can use, or we don't know the lengths that he's using yet, okay? So what we have to do is we have to call this X, and this side is X because they're the same. They're the same length, okay? Now, we know that he has 80 foot total, okay? He's got 80 foot total. So whatever he is, if he's got 80 foot total, he's got 80, whatever he's got left, he's got 80 minus 2x. That's what he has left because we're going to take 2x away, okay? So think about that for a second. If he, hypothetically, so let me draw another picture over here. Let's just say hypothetically, okay? Let's just pretend that he used 20 for this side and he used 20 for this side. That's 40 total. So then he would have 40 left for this side because 20 plus 20 is 40, and then 80 minus 40 would mean that this is 40 left, okay? So that's how we would arrive at that, and that's what we're doing. We subtracted to get that, okay? So let's get rid of that, okay? So let's give another scenario. Let's say that he used 10 for this side. Well, this side has to be the same because these sides are even. Well, 10 and 10 is 20. 80 minus 20 is 60. We just subtracted, okay? So that's how we're getting that. We just subtract these two together. 10 and 10 is 20 because we added those together. There's 2 of those, which is there's 2 of those, and we subtracted. That's how we're getting this equation right here, okay? That's where this is coming from, okay? So that's how we're getting this little equation right here. Now, we are coming up with an area. So what is area formula? How do you get the area of a rectangle? Area is length times width, okay? Length times width. So area is going to be X times 80 minus 2x, all right? So what we're going to do, this is going to be very similar to what we just did in Desmos, okay? We're wanting to find the max area that we can enclose with 80 foot of fence, okay? So what we're going to do is we're going to go back to Desmos, and we are going to enter this equation. So we're going to go to Desmos, okay? And we're going to type this equation in. So we're going to do X times 80 minus 2x, and that's going to give us, notice it gives us a parabola. Okay, now there's your parabola. If you go to the top here, your Y value is your maximum area. 800 is your maximum area. Okay? So 800 is your area. Okay, so if I write the coordinates of that point, 800 was your maximum area. I already forgot. Let's see. And 20 was the x, okay? 20 was the x. 800 was the y, but that represented your maximum area. So 20 was your x, okay? The dimensions of the garden to give this area was 20 feet. And if we want to figure out what the length is, okay, well, this side is 20. We need to figure out what this side is. So this is 20, this is 20. So that's a total of 40. And 80 minus 40 is 40. And there's the dimensions of our garden. Okay? Or you can do 80, we could plug that in here. You could do 80 minus 2 times, 20. And that also gives you 40. You can plug it in however you want to calculate that. Okay? So let's do another one like that. Very similar, we're going to set it up the same way. A farmer has 230 fence to enclose a rectangular garden using a river as one side of the rectangle. Okay? So this time we have a river. It's the same way, except we're just doing a river instead of a barn. Okay? All right, so we have x and x, and we're going to do 230 minus 2x because you've got the 1, 2. There's two sides, 230 minus those two sides. And if you're doing area, it's x times 230 minus 2x because there's your, remember area is length times width. There's your length and your width right there. We'll type that into Desmos. So let's go back to Desmos and we'll type that in. So we've got x times 230 minus 2x. All right, so let's go find the top of this parabola. Let's see, we got to go way up. Let's just zoom out a little bit here. There we go. Okay, so my numbers are 57.5 and 6,612.5. Okay. So 57.5 and 6,612.5. So this was the X, this was the Y, which represented your area. Okay, so the 6,612.5 was the maximum area. The 57.5 goes here. And then I have to plug the 57.5 in here. So I do 230 minus 2 times 57.5, which is going to give me 115 when I plug that in. Okay. So that's how you do those type of problems. Okay. The next one, very, very similar. Okay, but it's a two-part question. So Farmer Brown built a rectangular pen for his chickens using 12 meters of fence. He used one part of one side of his barn as one length of the rectangular pen. He maximized the area using 12 meters of fence. Okay, so this is the first part of our question. Okay, let's not worry about Farmer Johnson for right now. So let's just do Farmer Brown. Okay, so let's do Farmer Brown. So here is, he's using, here's the side of his barn. So I'm just going to do red for this barn. All right, so here's his fence. We've got X and X, and he's using 12 total meters, so we've got 12 minus 2X. We're doing that the same way. And we need to do X times 12 minus 2X. All right, we need to go back to Desmos. So x times 12 minus 2x. All right. So his maximum area is 18, and his x is 3, so 3 and 18. Okay, so his x is 3, and his maximum area is 18. Okay. So now let's do Johnson. Let's see what it says about Johnson. So we'll squeeze Johnson in right here. So it says Johnson built a rectangular pen for her chickens using 16 meters of fence. She used one side of her barn as one length of her rectangular pen. Okay, so let's do her barn. Let's draw it right here. The length of her pen was 2 meters more than the length. Okay, so let's figure out what Brown's pen was. So if we do 12 minus 2 times 3, so let's figure out what let's go figure out Brown's dimensions real quick. So 12 minus 2 times 3, that's going to be 6. So this right here is 6. Okay, so the length of her pen was 2 meters more than the length of Farmer Brown's. So if Brown's was 6, Johnson's has got to be 8, because if it's 2 meters more, it's got to be 8. The width of her pen was 1 meter more than the width. So if Brown's was 3 and Johnson's was 1 more, it's got to be 4. Okay, so this is over here is 4. How much larger is Farmer Johnson's pen than Farmer Brown's pen? So since it's talking about square meters, we're comparing areas. So Farmer Johnson's area, 8 times 4, is 32. So if we're comparing areas, we need to compare this area, 32, to 18. So 32 minus 18 is 14. So 14 square meters is our answer. Okay. All right, and last question. The heights of two different projectiles after they are launched are modeled by f of x and g of x. The function of f of x is defined as we get an equation here, and then we have a table for g of x. What is the approximate difference in the maximum heights achieved by the two projectiles? So we're comparing an equation and a table. So let's enter our equation into Desmos. So our equation, we have negative 16x squared plus 42x plus 12. There's our equation. And we have a table. So remember, do a table. You go to the plus and hit the table here. So we have 0, 1, 2. And then we have 9, 33, and 25. Now, we have to compare heights of these parabolas. You cannot just compare the dot to the parabola. So we have to do that equation that we just did in the previous lesson, whether you were in class with me or in the video. So I got to do that equation. So I've got y1 squiggly line equals ax1 squared plus bx1 plus c. All right, now what I want to do also is I need to change my color here so that makes it a little less confusing since they were both blue here. So I need to compare the heights of these two. So the height of my table is smaller, obviously. So the height of my function, the height of f of x, is 39.6 approximately. So I'm going to do 39.6 minus 34. So 39.6 minus 34. So let's write that down. 39.6 minus 34 is going to be about 5.6. Okay, so that's how you would do a problem like that. It's comparing two different functions. They give you two different formats. So you would have to plot those points and get your equation and subtract those two different heights.